Hello learners, this is Akash. I completed my BTech from NIT Rourkela in the year 2020. Currently I'm a mathematics teacher. Now let's see how to solve this given question. Here we need to solve this differential equation basically. Okay, and they are also saying that after solving the differential equation, we need to find out the exact solution. For that they have given that the solution of that of this differential equation, I mean, passes through this 1 comma pi by 4. Fine. Let me go step by step, okay, so that you won't get confused. It's a pretty simple one, but stay with me. This is what they have given. We need to do some things, okay, so that I can convert this to dy by dx is equal to something. See, I want to convert this to dy by dx is equal to something. Why? Once I get there, I'll tell you why I want. Now if you see here, there is dx, right? I'm sending it to the RHS, so this would be y dx by dx minus x dy by dx. Fine. Dx cancel. This is what I'd get: x sine square y by x is equal to y minus x dy by dx. So if you see, I got dy by dx here. Okay, now next what I'm going to do is send this minus x dy by dx to the LHS, so it would be plus it will be x dy by dx. Fine. And next send this my x sine square y by x to the RHS, so this will be y minus sine square y by x. Fine. I send this one here, so it became plus x dy by dx, and I send this one here, so it became y minus x sine square y by x. I hope things are clear up till now. Next, I want to write this like dy by dx is equal to something. Here I have x into dy by dx. Just send the x to the RHS. If I were to do that, I'd get dy by dx is equal to this numerator divided by x. Fine. Now if you'll observe, the numerator is a homogeneous function of degree 1. Likewise, the denominator also is a homogeneous function of degree 1. Whenever we get something of the form dy by dx is equal to one function divided by another function, like this is a function and this is another function. Next, if both of the functions are homogeneous functions with the same degree, I mean this one's degree is 1, this one's degree is 1, in that case this becomes a homogeneous differential equation. Fine. I do not want to cover that in detail here. Fine. If possible, I'll make a video on that someday later. Fine. So it is a homogeneous differential equation. Fine. Now what is the technique to solve such homogeneous differential equations? Pretty simple. We need to put y as vx. Fine. Now I'm going to differentiate both sides with respect to x. Fine. Now if I were to do that, if you observe on the RHS, I have two things, v and x. Fine. So I need to apply UV rule of differentiation here. So if I were to do the dy by dx, I'd get as v into derivative of x plus x into derivative of v. This is what I'd get. Fine. Derivative of x is nothing but 1, so v into 1 would be nothing but just v. So I'd get dy by dx is equal to v plus x. Derivative of v is nothing but dv by dx. Fine. Let's just keep things there. Fine. Now next, if you observe in this equation which I marked as 1, in place of dy by dx I'll be putting v plus x dv by dx, which I just showed you, and wherever you see y, for example here and here, in place of y I'm going to put vx. Right? That's what I told. I'm going to put y as vx, and in place of dy by dx I'm going to write v plus x dv by dx. Now with these changes, the 1 would become this. Fine. I hope things are clear up till now. Next, if you observe within the bracket here, there is vx by x. Okay, so x and x can get cancelled. After that, I'd be left out with sine square v. Okay, all good. Now if you see here, I have vx minus x sine square v. This becomes sine square v, as I just told. In these two terms there is x. I can take x common, I can take out x common. If I were to do that, I'd be getting something like this: x into v minus sine square v. Right? Now x and x would get cancelled. Ultimately I'm left out with this. Fine. Now if you see here, there is a v and here also there is a v can get cancelled, so I'm left out with this x dv by dx is nothing but minus sine square v. Fine. Now send this dx to the RHS, so I get x dv is equal to minus sine square v dx. Fine. Now I want to get all the v terms to one side and x terms to another side. If I want to achieve that, for that purpose I can just take this x to the RHS and take this minus sine square v to the LHS. So I'd get dv by minus sine square v is nothing but dx by x. Fine. This came here and this came here. Pretty simple. Fine. Chalo. Now 1 by sine theta is cosecant theta. So 1 by sine square v is nothing but cosecant square v. Okay. So I have minus cosecant square v dv is nothing but dx by x. Fine. With this, okay, just integrate both sides. Just integrate both sides. Now integration of cosecant square v is nothing but minus cot v, and there is already a minus outside. So minus of minus cot v is nothing but log mod x plus c. Now if you see, like integral dx by x, right, like integration of x is now 1 by, I'm sorry, integration of 1 by x is nothing but log mod x. That's why I have this. So just simplify it. So I get this cot v is equal to log mod x plus c. Now this v is something we introduced. Fine, it was not there if you remember. Now I want my answer in y and x. For that, what I'm going to do is cot, this I can write it as cot of y by x. Why? See, y is nothing but vx. That's what I put my substitution as. So send x here. So y by x is nothing but v. So in place of v, I can put y by x. That's what I have. Chalo. Now this curve passes through 1 comma pi by 4. Fine, this curve passes through 1 comma pi by 4. I mentioned in the beginning. Fine, so in place of y and x, I can put pi by 4 and 1. Or in simple words, in place of x put 1, you can put 1, and in place of y put pi by 4. If I were to do that, this is what I'd get. Log 1 is 0. So cot pi by 4 is nothing but 0 plus c. Cot pi by 4 is nothing but 1. So 1 equal to c or c equal to 1. So in this equation, just put c as 1 and then we are done. The equation of the curve is cot of y by x is equal to log mod x plus 1. Fine. Thank you very much for staying with me up till now. Fine. In case you like this video, please hit the like button. It will encourage me to make many more of such videos. And if this is your first time coming across to my channel, please do subscribe to it. Not just this question, I made some other questions based on this topic and other topics as well. Please check out the description for some other links. Thank you.